Hi friends, in this video we're going to talk about how to compress images in bulk with Python Pillow module. By the way, the whole content of this video is present in this blog post. I have given you the notes and the source code, so please be sure to check out the link of this blog post in the description of this video. So why do we want to compress our images? The main reason can be to save the storage space in our cloud or local disk. So in this video we're going to talk about two ways to compress our images. One is to decrease the resolution of the images, and the other way is through JPEG compression. So we're going to do a demo in this video, and when I compressed an image of 9.1 MB which is of this resolution to this resolution, I got an image which is of only 439 KB. So we have reduced the storage space of an image substantially. Imagine compressing 1000 images in your phone. It will provide a lot of storage saving. Alright, how are you going to compress our images in Python? Well, there is a Python package called Pillow, and we are going to use two functions of the Pillow Python module. One function is the thumbnail function. Basically, it resizes the images to a reduced pixel value. And the second image is the save function, which will save the image file to disk. And while saving, we can specify the quality parameter, and quality parameter will specify the compression. So if you give less quality, there will be more compression, and you'll have some storage space saving. And installing the Pillow Python module is really simple. Just use pip install pillow. So we're going to use the thumbnail function to resize the image, and we're going to save the image with some JPEG compression to achieve the image compression. Alright, after compressing images, you might want to copy the metadata of the images also. For example, today you have compressed your past 1 year's images, and after compression, the modified time of all the images would be current time. So you can't have a chronological ordering of your images after compression, and it would be pretty annoying. So you might want to copy the metadata of the images also to the compressed images. So how can we do that? It's really simple actually. You can just copy the modified time and the last access time of the source image to the compressed image. And that can be done very easily using the os.stat. Using os.stat, you can fetch the modified time and the last access time. And using os.utime, which is update time, you can apply those source modified time and last access time to the compressed image. Not only last access time and modified time, images also have some data called EXIF data, which is exchangeable image format data, and in that there will be data like what device or what phone the image was captured with, what are the GPS coordinates, what is the exposure of the camera, so on and so forth. So there is some image related metadata which is called the EXIF data. So you can even copy the EXIF data to the compressed image so that you don't lose the image related metadata. So how can you copy the EXIF data? It's really simple actually. There is a module called PyEXIF module. So this way you can copy the modified time, last access time of the source image to the compressed image, and also the EXIF data, which is the image data, to the compressed image, so that most of your metadata is preserved in your compressed images. Alright, enough of theory. Let's try to do some coding. I'm going to take a blank folder and let's try to open it with VS Code so that we can write some Python code. And to demonstrate the image compression, I need to have some dummy source files, right? So I've got this folder called C test1, and here let's try to see this image. This image is 4096 into 3072 pixels and the size is 9.1 MB. So imagine 100 images like this or 1000 images like this, you will have 90 GB covered already. So let's try to compress this image. And after we compress one image, let's try to iterate through all the images in a folder and compress all the images. So let's try to compress this image first. So I'm going to right click the image and copy as path so that I will get the path of this image. Let's try to create a Python file. I'll just name it index.py. And in fact, before writing the Python code, let's try to install the Pillow and PyEXIF modules. So I'm going to open a command prompt and I'm going to write python -m pip install pillow. So let's try to install Pillow Python module. Alright, we have installed the Pillow Python module. The same way, let's try to install the PyEXIF Python module. So I'm going to write python -m pip install PyEXIF. So we have installed the PyEXIF Python module also. First, let's try to import the Pillow Python module. So I'm going to write from pil, which is Pillow, import image. So we're going to load the image using this image class. Let's try to get the path of the image. So I'm going to write source image path equal to the path we've just got. Since it has backslashes, let's try to use the raw string, or else you can use double backslash also, but I'm convenient using the raw string. Alright, I got my image path. I need to compress this. So first let's try to load the image. So I'm going to write image equal to image dot open of the source image path. So to compress the image, I need to reduce the resolution to a lower resolution, right? For that, let's try to see what is the source resolution. And if the source resolution is more than a particular resolution, let's try to reduce the image resolution. So first let's try to find out the width and height of the image. So I'm going to write width comma height equal to image dot size. So image dot size will give you a tuple which contains the width and height of the image in pixels. So for this example, let's try to resize the image if the width is more than 1080 pixel. So I'm going to say something like max width equal to 1080. So I'm going to write if width is greater than the max width, then I'm going to resize the image using the thumbnail function. If the width is greater than max width, the new width is going to be the max width. But what is going to be the new height? The new height should be proportional to the original height, right? So let's try to use some simple math. So I'm going to write new height equal to height into the multiplication factor would be the ratio of the new height by old height, right? So I'm going to write new height is max width by the old height is height. So I've got my new height also. Now let's try to resize the image to the new height and the max width. So I'm going to write image dot thumbnail of, and here you need to give a tuple which is the new dimensions. The new dimension is max width and new height. So I've resized the image to lower resolution here just by this one line of code. So I've compressed the image. I need to write it to a file, right? Let's try to do that now. So I'm going to define the destination path also. So the destination image path would be something like test1.jpg. So I got my destination image path. Let's try to save this image now. So I'm going to write image.save, and the image path would be the destination image path, and the file format would be the JPEG file format. And additionally, you can use a quality parameter, which is quality equal to, if I write 100, there will be no JPEG compression. And if I write something like 90, you will have some JPEG compression. It's like zipping a file. So instead of hard coding it, let's try to extract it to a variable. So I'm going to name a variable called quality, and let's try to define it here at the top. So that's it. We have did the JPEG compression here, and we have resized the image here. It's really simple, just 2 lines of code. All of this is just setting up the image for compression and resizing. Now let's try to run this code. And after your code is run, you need to get a file called test1 in the same folder. Let's try to see the image, and you got the test1 image. Now let's try to open this test1, and here the width is 1080 and the height is proportionally 810 pixel, and the size is only 594.9 KB. I mean, if I change the quality to something like 90 and save this and run this again, the size is 437.6 KB. And I'm okay with this image quality. For long-term storage, I'm okay with this quality because I'm getting some pretty good storage saving. Alright, we have saved the image, but before saving the image, let's try to copy the metadata also. First, let's try to copy the image modified time and access time. For that, you need the OS module, which is an inbuilt Python module. So I'm going to write import OS, and then here, let's try to get the os.stat, which contains the image modified and access time. So I'm storing it in a variable called src image stats. So os.stat of the source image path. And here I'm using the os.uTime, which is update time. And here in the destination image path, I am setting the access time and the modified time from the source image. So we have copied this metadata of the last access time and the modified time successfully by just this 2 lines of code. Alright, now let's try to copy the exif image metadata, which is some image related metadata like what was the device with which the image was taken, what was the GPS coordinates of the image, what was the exposure, saturation, etc. For that, let's try to import the pyexif module. So I'm going to write import pyexif. So exif data can be obtained as a Python dictionary, something like this. So here pyexif.load, and you need to write image.info of exif. So you will get an output dictionary which is the exif data. And this exif data can be saved to the destination image while saving it as a file. So here after quality, I can even write exif equal to pyexif.dump of the exif data. This exif data is extracted from the source image. So I am using the exif data from the source image and dumping it to the destination image path. In fact, let's try to get the exif data before even changing the image. So I'm going to get the exif data before resizing the image. Alright, but there is some catch here. Some images might not have exif data. Then you will get an error like there is no attribute called exif in this image.info dictionary. For that, let's try to create a simple if clause. So I'm just writing if exif is present in image.info, then get the exif data, or else make it a simple blank dictionary. Well, unfortunately, there is one more catch here. When you're dealing with some images, you will get an error for this 41729 key inside the exif data. This was some bug already flagged in the PyExif module. So you can easily go through this bug by converting that 41729 value into a string. So just copy paste this and that bug should not be present. So we have just seen if exif is present, extract the exif data and do a simple bug handling for this PyExif dictionary. Otherwise, make the exif data as a simple dictionary. We have copied the exif data and then pasted it in the destination image while saving it. And we also copied the last modified time and the last access time from the image using the os.stat and os.utime functions. And that's it. We have very easily copied the metadata also from the source image to the compressed image. So let's try to run this code, and we got image compression complete. And let's try to omit the image. As expected, it has the same size. And let's try to right click and see the image properties, and we have got the modified time and access time as expected. And let's go to the details, and here in the details you can see the image related information also present in the destination image, which is the dimensions, width, vertical resolution, compression, camera details, and all this metadata. Now instead of processing one image, let's try to process all the images in a folder and dump those processed images into another folder. Let's try to do that. So for that, I'm going to import the glob and pathlib Python modules. So I'm going to write import glob, and here I'm going to write import pathlib. And let's try to declare the input folder, and the input folder was C test1. So we're going to iterate through all the JPEG files in this input folder and create the files in an output folder. So the output folder would be something like C test2. I will create this C test2 folder. So we have created this C test2 folder. So we're going to use the glob Python module to iterate over the files inside the input folder. So I'm going to write glob.glob and input folder /star.jpg. So all the JPEG files would be iterated in this for loop. This is the image iterator, which would be something like 0, 1, 2, 3, and this is the image part, which is the image absolute path like C test1 image1.jpg, C test1 image2.jpg, something like that. So let's try to print the image iterator and the image path, and then outside the full absolute path we need to extract the image file name. So using the pathlib.path of the image path.name, you will get the file name, and the output path would also be the same file name but in a different folder, right? So I'm using os.path.join out folder and the out file name, which is the same thing as the source file name. So I got my output file path and file name. Now I need to compress the image. So let's try to extract this whole source code into a function. So I'm going to write def compress image, and let's try to indent this to make it under a function, and let's try to give some inputs to this function. The first input would be the source image path, and the second would be the destination image path, the third would be the max width, the fourth would be the quality, and I think we have covered everything. So let's try to call this function here. In fact, so let's try to copy this compress image and call it here. So for the compress image function, I have given the input image path, the output file path, max width, and the quality. So we can remove this source image path and destination image path here, and that's it. In a for loop, we are compressing each image and dumping it to an output folder. Let's try to save this and let's try to run this. Alright, we did a mistake here. Well, you can't set the modified time and access time before even creating the file, right? So after saving the image, I need to set the modified time and last access time. So let's try to cut this and paste it below the image.save. And let's try to run this code again. Now I did not get any errors and the image compression is complete. We have processed the 5 image files present in the input folder, and we have to see the images in the test2 folder. Let's try to go to C test2, and I got my images. Let's try to see each image. Looks fine for me. And let's try to right click any image and see the image details. So I've got my modified and access times as expected, and in the details I'm even seeing the image metadata, which is the exif metadata also. So as expected, we have compressed and copied the metadata from the source image to the destination compressed image. And that's it. With very less lines of code, you can compress thousands of images to save your storage space. You can see I have created a blog post on how to compress images in bulk using the Python Pillow module. I have given you the notes, the source code, and also the links to the official documentation so that you can do further reading. You can go through the Pillow documentation to do more image processing other than just image compression. Please ask questions or post your valuable feedback in the comment section. Hope you like this video guys. Thank you for watching. Peace.